Hello everybody. Let's briefly touch upon the evolution of onboard diagnostics and vehicle diagnostics. Well, to touch upon history and evolution, I am sure you may find this slightly mundane or boring. It may be a tad tedious, but just for information's sake, I want all of you to know that evolution of vehicle diagnostics started way back in 1960s. The first in 1968, the first time Volkswagen introduced the first onboard computer in its Type 3 model to optimize fuel optimization. So, in way back in 1968, only one parameter, the fuel injection, was monitored or uh, controlled by by Volkswagen, by the onboard diagnostics present in the Volkswagen car. These analog systems were these early systems were analog and lacked diagnostic capabilities. The focus was primarily on improving engine efficiency and reducing emissions. Now, when it comes to rise of electronic control, 1970s to 1980s, the 1970s environment concern led to Clean Air Act. This was the time where severe smog was found in Los Angeles, and US car makers were under tremendous pressure to reduce the emissions, where suddenly the governments throughout the world woke up that automobiles are the major contributor to the worldly emissions, and suddenly lot of emission activities or a lot of emission control activities were enforced on the automakers. And by 1979, Society of Automotive Engineers proposed standardizing diagnostic connectors and signals. And in 1980, General Motors introduced assembly line diagnostic link, a proprietary interface used during manufacturing. General Motor rolled out computer command control system which monitored engine functions and emissions. All right, so these are the early beginnings, or these are the how to say baby phase of the onboard diagnostics. Now, when it comes to OBD-I, the first generation, 1988 to 1995. Well, this is something which I touched upon, but just for sake of a revision, it monitored emission-related components. It used manufacturer-specific connectors and code, no standardization. It provided very limited data and required specialized tools. And slowly it evolved to the OBD-II, which is even today prevalent in many automobiles. And by 1996, OBD-II became mandatory. Now, key features again: standardized 16-pin connector, universal diagnostic trouble, real-time access like engine RPM, vehicle speed, and emission status, and supported communicator protocol including CAN. Okay, beyond OBD-II, telematics, and OBD-III. Now, when it comes to OBD, after OBD, telematics is making a rapid foray into the onboard diagnostics. Telematics is nothing but it is like a word is coined from telecommunications and informatics. Okay, now OBD-III proposed it allowed remote diagnostics via wireless communication, integration with telematics system enabling the fleet management, predictive maintenance, driver behavior analysis, and vehicle can now transmit health data to service centers or manufacturers in real time. Global variants, well, these are I briefly touched upon. EOBD is there, JOBD, which is Japanese version of the onboard diagnostics. HD-OBD stands for heavy duty. Impact on the automotive industry. Well, this led to the efficiency and far more accurate troubleshooting. Gone are the days where a mechanic had to go through the entire car to understand the problem. Now, a mechanic can easily pinpoint where exactly the problem is. Now, when it comes to environmental compliance, ensures vehicles meets emission standards and consumer empowerment. Okay, now even the consumer, the driver or the owner of the car is also empowered to use the scan tools to monitor the vehicle health. So this is more like you are educating the owner of the vehicle about the interior of the vehicle. Now, when it comes to future of OBD vehicles, OBD-II real-time emission reporting, enhanced cyber security, OBD-III. Now there are some cyber security concerns. Even though OBD-II is doing a good job, there are some cyber security concerns. Those concerns are addressed in OBD-III. And integrated vehicle health management, which is used in aviation. This is now entering into automotive. It combines sensor data with AI for proactive maintenance. And electric and autonomous vehicle diagnostics like EV specific monitoring, battery health and charging systems. Now coming to the self-diagnosing autonomous cars, AI-driven fault detection and self-repair suggestions. Now it is not only diagnosing. In future, autonomous vehicles can even give a suggestion how to repair, what to repair, and where to repair. What exactly needs to attention, that also self-diagnosing autonomous car can suggest. So from basic mechanical checks to AI-driven predictive diagnostics, vehicle diagnostics have come a long way. Okay, so OBD-II remains the backbone of modern diagnostics, but advancements in CAN bus, wireless connectivity, and AI are shaping the future. Now, as cars becomes more connected and autonomous, diagnostics will continue evolving toward real-time, cloud-based, and predictive systems. Okay, so this real-time, cloud-based, and predictive systems is the future as on now, as far as now is concerned. Okay, so I hope all of you got a brief idea about the trajectory of the onboard diagnostics. Thank you.